Welcome to part 7 of this CODM tutorial. In this video we will learn how to set up tremulants. In the CODM there are two ways to set up tremulants. You can use an artificial tremulant or use sampled tremulants. The artificial tremulant makes use of special tremulant waveform samples. These define the modulation of the pitch, amplitude and harmonic shaping for the tremulant. The custom example organs comes with several tremulant waveform samples you can use, but you can also use the organ's original tremulant waveforms. We can find the tremulant waveform samples for the example custom organs in installation package 1. Here we can find tremulant waveforms for several ranks. The tremulant waveform samples must be named in the same way as we see here in the example custom organ, with MIDI note number and note name. If the tremulant waveform samples of the original organ are named in another way, you should copy them into a folder in your organ's installation package and rename them in the same way as in the custom example organs. I will show how to do this in detail in the next video about noises. Let's set up an artificial tremulant for Manual 2. First, we have to make an entry in the tremulant table. But as we can see here in our organ, our tremulant table is empty. So we will copy one from example custom organ 2. Copy. And we paste it here. And now we only have to change some parameters. The tremulant code defines the role for a tremulant. Let's look in the database table to see what code we should use. The tremulant code. We need a tremulant for Manual 2 main, and that's code 1720. And that's already here. Here we write a name to identify the tremulant for our own reference. We'll name it Tremulant Manual 2. Now there is a row for custom display. Since we're not using that for the moment, we leave these blank. The display name is the name shown on the default controls page. We'll call it Tremulant 2. The sound effect parameters are for the tremulant noises. We leave these blank for now. The frequency defines the speed of the tremulant in Hertz. Here you can set the speed of the tremulant, so you can match it to that of the original organ's tremulant. The database table gives a default value of 5 here, so we can start with that. The other parameters are well described in the database table. Now we can set up the tremulant for one of our stops. Let's set up the tremulant for the quintatone 8 using the tremulant waveform samples of the original organ, which is the Dingelstadt organ. We have to go to the rank table and set up the tremulant parameters for the quintatone. Here we see the tremulant parameters. The quintatone has 2 ranks, so we have to do that for both ranks. We change the tremulant code to 1720, which is the code for our tremulant on Manual 2. For the next 2 parameters we have to find where the tremulant waveform samples for the quintatone are. This can involve a little searching. Sometimes they are in the rank folder, sometimes in the noises folder, and sometimes in a known separate folder. The quintatone samples are in installation package 1815, so let's see if we can find the files there. Let's first check in the ORTF folder for the direct perspective. Tremulant, and here we see the tremulant waveform sample files. So now we can copy the folder name and we can paste it in our CODM file. The installation package was 1815. And now we can do the same for the quintatone diffuse rank. The diffuse samples are in the LR folder, tremulant folder, and here we can copy the folder name and paste it in the CODM document. This parameter defines the maximum randomization of the overall depth of the tremulant, thus the amplitude, pitch and harmonics. This can be left blank, or in this case I use the default value 0. There are further fine-tuning parameters for the amplitude, for the pitch, and for harmonic shaping. You can find more detailed information about these parameters in the database table. Now let's save the file and open the organ in Hauptwerk. And as we can see, the tremulant automatically appears on the controls page. Now let's listen to it. It seems a little fast. I made a recording of the original organ so we can compare. Now let's adjust the tremulant speed here by right-clicking the tremulant. Let's set it to 4.1 and let's listen again. And now we're pretty close. In our CODM file we can change the speed here to 4.1 and there we have our tremulant. Now we will set up a tremulant using real tremulant samples. When we use real tremulant samples, we don't use the tremulant table in the CODM file. Instead, we will make an extra rank containing the tremmed samples in addition to the rank with the normal untremmed samples. We also need to make a stop for the tremulant in the stop table. Then we have to make some adjustments in the stop rank table so the tremulant stop will switch between the tremmed and untrimmed samples. I added the lieblich gedeckt 8 from the Dingelstedt organ to our organ. This stop has real tremulant samples, so we can set up a tremulant using these tremmed samples. Back to our CODM file. Here is the normal untrimmed rank for the lieblich gedeckt. So now we have to make a new rank with the tremmed samples for the lieblich gedeckt. I'll just duplicate this rank. We have to give this rank a new number. We can name it 27 and the new name lieblich gedeckt trem. And now we have to find the folders for the tremmed sample files. We will find these in installation package 1816. And here we can see both the untrimmed normal samples and the tremmed sample files. So now we can copy and paste the folder names into our CODM file. And now we have the folder names for the tremmed samples in place. Since we're using real tremulant sample files, we don't have to fill in anything in the tremulant parameters. Now we have to make a stop for the tremulant. We duplicate this stop. And we change the stop code to 2207. It has to be 22 because it's in the second manual 2. Tremulant 2, we can call it. And the display name can also be Trem 2. There we have our stop with stop code 2207. Now we have to make some adjustments in the stop rank so that the tremulant stop will switch between the tremmed and the untrimmed samples. Here is the stop rank for the lieblich gedeckt, and the first parameter we have to change is the stop code to switch to alternate rank. Here we have to fill in the stop code for the tremulant stop we just made. And that was stop code 2207. The next parameter about retriggering, if we set this to yes, then Hauptwerk will switch automatically to or from alternate rank while holding a note. So we'll set it to yes. The alternate rank ID, here we fill in the rank ID for the tremmed rank, which was 27. Now we can save the file and open the organ in Hauptwerk. And here we can see the tremulant stop we made. Now let's listen to the lieblich gedeckt with the tremulant. And here we have a lieblich gedeckt with the tremulant. As we can see here, we now have two tremulant stops, one for the artificial tremulant and one for the sampled tremulant. Using both tremulants simultaneously in one division is not advisable, since it can be very hard to get the speed of both tremulants synchronized. In the CODM, it's not possible to trigger both artificial and sample tremulant with the same stop. So if you have both artificial and sample tremulants in one division, you need two separate stops. We can, however, link these two stops together in the ODF file. I will show how to do this later in a separate video after we finished our organ. Changes in the ODF file should first be made when you have finished your CODM file. Because when you make changes in your CODM file, Hauptwerk will generate a new version of the ODF file that will override the existing ODF file.